In this illustration, we intend to simulate the masonry wall undergone the earthquake in the Abaqus software. The duration of the earthquake is 10 seconds, during which a transverse ground acceleration record will be applied to the bottom of the masonry wall and causes the wall to collapse. In the right picture, you can observe the diagram of the transverse ground acceleration record having been applied to the wall. In this question, the masonry wall has been modeled using simplified micro approach. In this approach, mortar has been used in order to connect the bricks together. The mortar is defined as interaction property. The interaction property includes adhesive behavior as well as damage behavior. And continue. The bricks will be modeled in form of solid with a length of 230 millimeters, the height of 76 meters, and are 110 millimeters wide. I'll draw a rectangle, enter its length as 0.23 meters, its width as 0.076 meters. Done. Enter its depth as 0.11 meters and OK in this manner. In this article, the Drucker-Prager model has been utilized in order to define properties of plasticity. I'll select plasticity and Drucker-Prager from a mechanical menu. The angle of friction is equal to 36 degrees. Flow stress ratio is equal to 1. And dilation angle is equal to 11.3 degrees. Again, I'll click on Create Instance, enter a brick into the Assembly section, click on Translate Instance, select this brick, done. First, I will select this node, then this one, and OK. I will click on Linear Pattern, select this brick, done. Here, we will use the simplified micro approach for modeling the masonry wall, and during this approach the bricks are modeled completely and assembled together, and here the mortar is not modeled in a separated part, but only the properties of mortar will be defined in the Abaqus software in form of interaction property. In fact, the mortar properties include cohesive behavior of mortar and damage behavior of mortar that will be defined as interaction property in the interaction module. To do so, I click on Create Interaction Property. Contact, continue, select Normal Behavior from the Mechanical menu, then select Tangential Behavior from the Mechanical menu, then Penalty. In this article, the adhesion properties and the damage properties have been mentioned. The friction coefficient is equal to 0.75, and I will enter that. Then I'll select cohesive behavior from the mechanical menu, select specify stiffness coefficients. In this article, KNN and KSS and KTT quantities have been pointed at. KNN is the stiffness of mortar in normal direction. KSS is the stiffness of mortar in the first shear direction. KTT is the stiffness of mortar in the second shear direction. The quantity of KNN is equal to 63 Newton per cubic millimeter. 63 multiplied by 10 to the power of 9 Newton per cubic meter. KSS is equal to 25 multiplied by 10 to the power of 9 Newton per cubic meter, and KTT is equal to 25 multiplied by 10 to the power of 9 Newton per cubic meter. Continue. Here you can observe the transverse ground acceleration record. I will select these two columns. Copy and paste them here. OK. Here I'll select transverse acceleration and OK. As you observe, the transverse acceleration directed at x-axis. Click on seed edge. Select these lines. Done. Consider 8 elements for them and OK. Then I will select these lines. Here you observe that the bricks come apart and become separated caused by the earthquake, and the mortar between them has been failed as well. Here you can observe the sections on the masonry wall where the bricks have become separated from one another. The bricks, as it can be observed, have come apart in this area and this area.